Yes, sir.
Yeah.
Yes, sir. Yes, sir. Audible, sir.
Sukni Singh is currently working as a principal scientist in renewable energy engineering and head of the mechanical engineering department. Sukni Singh joined PAU on December 1995 as assistant research engineer after obtaining MTech in mechanical engineering from PAU. He graduated in mechanical engineering from Carl Institute of Engineering and Technology, Patiala in 1991 and did PhD in mechanical engineering from National Institute of Technology NIT Jalandhar in 2012. Since joining PAU, he has been actively involved in developmental activities in solar energy. He established the state-of-the-art of solar energy teaching laboratory. He has completed one external funded research project on computational as a principal investigator. Presently, he is handling 2 projects on solar energy in the Department of Renewable Energy Engineering. Dr. Sukhmit Singh has 90 publications, including more than 25 peer-reviewed papers in journals of international reputed publications. He has developed popular technologies like packed bed solar air heater, scale-free solar water heater, multi-shelf domestic solar dryer, and forced circulation solar dryer. Thank you, sir. Now I welcome Dr. Sukhmit Singh to deliver a talk on solar thermal applications on agriculture field. Thank you, sir, for accepting our invitation.
Good afternoon to all the participants. Good afternoon, Dr. Srinivas.
Yes, sir.
Today, I will be talking with you about solar thermal application in agriculture. That is, I think, the most untouched application by the mechanical engineers. Mechanical engineers generally don't focus toward the agriculture applications, and but it has a great potential that you will see at the end of the presentation. You will be able to appreciate that it has a great potential. Yeah. There are a number of applications. I have listed just the 3. Like the first one is solar drying of agricultural produce, solar thermal water pumping system, and solar thermal refrigeration system. But we can list number of applications of solar energy, solar thermal energy in agriculture. We have listed just 3. Because all the applications have to compete economically with the other sources of energy, where the economics will fit in better. Only that application will get promoted, otherwise that will not be promoted. Firstly, talking about the solar drying of agricultural produce. About the drying of agricultural produce, it is, I would say, it is a necessity to dry agricultural produce, because of many factors like there are very high post-harvest losses. After harvesting, a very large quantity of crop is lost because of improper handling during post-harvest operations, and that also causes food insecurity in Asia and African countries. The food is also lost, you can see, in the developed countries, but in those countries, the food loss is at the consumption stage. Whereas in the developing countries or underdeveloped countries, it happens in the post-harvest and handling and processing. So, and that quantity loss of food is quite high, 1.3 billion ton as per the FAO. And the second thing, why we should dry the agricultural produce is because of the ever increasing population. It is the population is going to increase, and by 2050 we will be increasing about 70% more food as compared to that we are producing now. So there is a demand for more food as well. Only that can only be met if we are able to reduce the losses. That would be the better way. And there is a lot of scope of handling it in a better way to reduce the losses. Presently, even some of the crops are being dried, but those are being dried in open sun by most of the developing countries or underdeveloped countries. That is spread in the open sun and made to dry. But that is a very inappropriate drying method in which number of contaminants are added. And also, because of that poor drying conditions, aflatoxin contamination is very much there. And that is a great cause of health concern. What we need is we need to devise appropriate drying technologies for the reduction in post-harvest losses for so as to improve the quality of the food, and at the same time income generation and employment opportunities will be there. It is preferred that the drying technologies are such that they are available in the villages itself, so that farmers are able to process the food at their own location. Uh, you can if we process the food at the village, our transportation cost is reduced because the fresh food dries to 1/5 when it gets dried. About 1/5 is the moisture. Around every vegetable and fruit has a moisture content of around 80 to 90%, and the required moisture content is below 10%. So the weight reduction is very high. About fifth weight reduction is there. 5 times the weight reduction is there. Because of that, the transportation cost is reduced to a very low value. That is the advantage if we are able to process the food at the village level itself. So the technologies should be such that they can be used at the villages. And
Can kindly go to the previous slide, sir? Just previous slide.
yeah.
Just before that. Uh,
Want to ask something?
yes. Before that.
Yeah. Yeah, go ahead. Yeah, go ahead.
No, sir. No, sir. Just previous one. Just first.
Okay.
That
This one?
FPU. Yes. Okay. Thank you, sir. Thank you. FPU 2009. Okay, sir. Okay. Thank you.
Should we
Thank you. Yes,
move
you can
forward?
proceed now, sir. Yes, sir.
Okay. And
Sir, excuse me, sir. Kindly
if,
minimize please 1 minute.
pardon?
Sir, on your screen, kindly minimize that mask like it's coming.
Kylie?
Minimize that screen, sir. That's black. The display is coming.
Okay. Yeah, that's right.
Yes, now it's fine, sir. Thank you.
If the proper drying method is followed, if we process it properly, then we are able to reduce the moisture content of drying product to a lower value, to a desired value, generally less than 10%. Then its shelf life will increase. We can store up more than for 1 year. So that is the advantage in case to the processors, to the farmers, whoever process the product, because what happens is mostly when there is a glut in the market, the price of the product is very low. Farmer can process the product and keep it with him, and because now it has a storage life of 1 year. And when the prices increase, he can sell the product. That is the advantage of drying. And but the drying is a very energy intensive process that is known to us. And how the drying is done, that is a simple method that we supply the heat. In most of the drying processes, we supply the heat, and the moisture of the drying product comes to the surface, and air which is in contact with the product, that will carry the moisture, as well as the surrounding air will move away and the fresh air will come. That is generally the drying process that generally occurs if we normally dry with the help of heat. The traditional drying practice that we follow, that is open sun drying. That is followed in most of the Asian and African countries. And that is a very, you can say, inefficient drying. Its efficiency is close to 2 to 3%. Most of the heat that is absorbed falling on the product, solar radiation falling on the product is lost. Very small amount of heat, around 2-3% is utilized for moisture evaporation. Rest goes either is lost to the long wave radiation to the ambient, or convective losses to the environment, or conduction to the ground. That is done. And the another thing is that when we do in open sun, that has to be in a single layer. We can't put a thick layer, because the where the solar radiation is falling, only that layer of product will get dried. The product on which the solar radiation is not falling will not get dried. That will remain as it is and will decay eventually. So it has to be a single layer. So for drying, we need very large space. That is one thing. And the other thing is the environmental temperatures are at the maximum 45-46 degrees centigrade. At that temperature, we cannot go to a temperature moisture content below 10%. So the moisture content will remain higher. That will cause lower shelf life of the drying product. It may be 3 months or 4 months like that, because we are drying at a higher temperature. The other parameters that are not in favor, like the environmental parameters are there, the dust will be added, and whenever the weather goes bad, we have to collect the produce and then again spread when the weather sun is shining. And in the evening, we have to collect the produce, and then in the morning again spread the produce. So it is a labor intensive as well. So, but because of the cost, most of the farmers prefer open sun drying. And since the other methods are not available, which are as economical, or you can say close to that, the other dryers that we have are very costly. The other drying methods, like we have, are electric drying, vacuum drying, that can be done using a vacuum dryer as well. Biomass as a fuel can be used for drying the crops, and heat pump drying is there. All these methods require large amount of energy. They are energy intensive, that is one thing. And the problem in the villages is that the electric supply is not reliable. That is one thing. Even if we can make a system that is that consumes lesser energy, but the electric supply is very unreliable in the villages. So we will have to shift the system to a place in a city where the electric supply is reliable. That is one thing. To have the system working at village, we need to go in for such a system, like for a solar energy system, where the fuel is reaching every nook and corner of the country, in the villages itself. Only utilization has to be done. Fuel is there. The solar energy is there almost everywhere, at least in India. And mainly the issue with other systems like electric, vacuum, or biomass or heat pump is the availability issue. Because of that, we cannot go in that direction. But these are being done by the large commercial houses. They can do at a particular place. They can ensure the availability. That can be done by them only. So solar is promising from that point of view, and it is available almost everywhere. And now, what is solar drying? That we know it is just by placing that in the sun. But in addition to that, we are using the sun radiation, and in addition to that, we need to have some equipment that is able to collect the sun rays and utilize that collected energy for drying of agricultural produce. That is a solar dryer. So as compared to, it has certain advantages, very large advantages, you can say, as compared to the open sun drying. It is faster, as you know, it is hygienic, it's healthier, These things are there because the dust and other impurities will not be added, and the shelf life of the dried product will be more because with it we can dry to a lower temperature because we can achieve a higher temperature in the solar dryer. Product will be dried at a higher temperature, so the moisture content will be lower, so the shelf life will be more. And its operating cost as compared to the mechanized dryer, the other dryers, electric or vacuum dryers, is lesser. So these are some of the advantages, and very large amount of work has been done on solar dryers, and there are number of technically proven designs, but the potential is there, requirement is there, but it has not been used uh, in you can say it is uh, very few locations it is being used. Where it has been developed at that location it is being used. These have not been popularized. There may be there are certain limiting factors because of which the extension activities because of which they have not been popularized because we have not educated the farmers about the use. And here I have shown the list of a few products with their initial and final moisture contents. You can see in second column, it is the initial moisture content of the product, and this is the final moisture content of the product. Final moisture content for most of the vegetables and fruits is less than 10%. For grains, it is between 10 to 15%. It's like that. And for fruits like or okra, this vegetable okra, it is 20%, but mostly it is 10% or around that. And the allowable temperature you can say is maximum up to 75 degrees centigrade, but mostly for the fruit and vegetable it is between 50 and 70 degrees centigrade, and for grains it is slightly lesser. So the temperature required is up to say 75 degrees centigrade, and this can be easily achieved with the flat plate solar collectors. So the solar collectors seems more suitable for use as a in a solar dryers, so because we can easily achieve the desired temperature with them. And about the components of the solar dryer, basically we have two components. Like we need to collect, we have need to have some arrangement to collect the solar radiation. That is the solar collector. And the other, we need the arrangement to utilize the collected energy. So
Yes.
in the solar dryer, the main components are we have to collect the solar energy and we have to utilize the collected energy for drying of agricultural produce. For the collection of solar energy, we have solar collectors, and for utilization of solar energy for drying of agricultural produce, we have dehydration chambers or drying chamber. So these are the two main components that would be there in all the drying systems. The additional components may be there, but these are the basic components that have to be there. And about the classification of solar dryers, the solar dryer can be classified in three ways. These are based on the collection and utilization of solar energy. How do we collect the energy and utilize that energy? And then the mode of heat transfer, how the heat is transferred from the absorber, the collected heat, to the agricultural product, how the solar radiation is transferred. And third is the method of air movement, how the air moves. Based on the three, First is based on collection and utilization of solar energy. This we have seen the solar dryer has two main components, solar collector and drying chamber. And if they are combined together, the solar collector and drying chamber are combined together, then that system is called the integral type of system. And the other possibility is we can keep them separate. Solar collector and drying chamber. So the second possibility is solar collector and drying chamber are separate units. So that is a better unit that is called the distributor type. Here in this case, we can optimize both the units. Solar collector can be separately optimized and drying chamber can be separately optimized, and then they can be combined together. So we have two types based on collection and utilization of solar energy, integral type and distributor type.
Your slide
We
is
have,
not visible.
Yeah, it's showing. It's
Right. It is
slide is
visible.
coming, sir. It's coming. Mode of heat transfer.
now we have mode of heat transfer. Is it
Yeah, visible.
sure? Sorry. About the mode of heat transfer, we have three types of solar dryers. One is a direct solar dryer, other is indirect, and next we have is a mixed mode solar dryer. In the direct solar dryer, the the radiations are captured on the produce itself, directly utilized. The produce gets heated and the moisture is removed from the drying produce. And in the indirect solar dryer, the agricultural produce doesn't come in contact with the solar radiation. Hot air is utilized to dry the product. That is an indirect utilization, indirect solar dryer. And in the mixed mode, it is a combination of both the indirect and direct mode. That is the mixed mode. This is the example of direct type solar drying. Like it is like in the open, we spread this this product, and then it is covered with a transparent glazing. That becomes a direct solar dryer. Openings are provided for airflow at the bottom and at the top. Solar radiation fall on the produce gets heated, its moisture comes to the surface as it gets heated. And the air which is in contact with the produce also gets heated, and that picks up the moisture and leaves at the top. As it leaves at the top, equal quantity of air from the bottom will come in, and this process will continue as long as the radiation is falling on the produce. So this is a direct type of solar dryer. And some of the points in its favor or against are like it will be of small capacity, because we have to spread the produce. Only that much drying produce will be there, and we have to cover that produce. So the area required will be very large. So we can process limited quantity of produce at a time, and discoloration of produce will be there. Most of you may have noticed, like in the case of red chilies or fenugreek leaves that we call methi, leafy vegetables. If direct sunlight falls on them, their color is affected. So discoloration is there because of direct solar radiation. But if we dry them under shade with hot air, no discoloration will be there. And because of the heat directly falling, there is a localized heat damage may occur. And it is not suitable for deep layer drying. We cannot have a bed, the drying bed of very large thickness. It will be a single layer. Only then the drying will be accomplished. And the other thing that the selective coatings that we use in solar air heaters or solar water heaters to enhance the performance, that cannot be used in this case, because the product itself is an absorber. And this is an example of indirect solar drying. It is the simplest example. Like we have a solar collector, we have a solar collector here at this, which gets heat from the sun. Air, there is an opening for air inlet at the bottom. Air moves upward. Hot air which comes in contact with this absorber will get heated. It will move up. And here we have a drying chamber. It will, as it moves out, it will pass through the drying produce and leave at the top by removing moisture from the product. So this is an indirect solar dryer. Radiation are falling on the solar collector and no radiation is falling on the produce being dried. And these are some of the points about the indirect solar dryer, like it offers a better control over the drying and the product obtained is of better quality than direct solar drying. Localized heat damage do not occur as the crop are protected and can be operated at a higher temperature. Like we can have large number of solar air heaters so that we get the higher temperature at inlet to the drying chamber. And it is recommended for photosensitive products that I talked with you about, the red chilies and leafy vegetables. Those will be better dried in this case. And about the mixed mode solar dryer, it combines the features of both direct and indirect solar dryer. This is a mixed mode solar dryer. Here we have a solar collector, and at the top we have a drying chamber. The solar this is the drying chamber, and at the top of the drying chamber we have a transparent roof. So the product trying to be dried is placed here. It is getting heat from the solar air heater from the bottom in the form of a hot air and directly from the solar radiation as well. So it is a mixed mode. We are getting drying through an indirect as well as direct. The two modes are combined, so it becomes a mixed mode. Some of the disadvantages. The disadvantages of the open sun drying remain, like discoloration of crop due to direct exposure, localized heat damage, that will remain, although their extent will reduce, but it will remain. Then next is the method of air movement. This is in this case, we can have the air movement through the solar collector and drying chamber naturally by buoyancy, or we make use of an air blower or a pump to force the air from the solar collector through the drying chamber. So these are the two types of dryers: natural airflow or forced airflow. These are also called passive solar dryer and active solar dryer. Now, like we have seen, this is the earlier seen for the direct solar dryer. This is the passive solar dryer. The radiation is falling on the produce. The product is getting heated. Air in contact is getting heated and moving at the top, leaving at the top. So this is a passive solar dryer. It is the one thing that is in favor of the natural circulation or passive solar dryer is that it can be used at remote locations where electricity is not available in villages. So, but it is best suited for drying small quantity of fruits and vegetables. We cannot dry large quantity because we have to occupy, it will occupy that much area. The system has to be very large. The product has to be spread in a single layer. And about the active solar dryer, we have to make use of a pump. Here we are making use of pump and forcing the hot air from the solar collectors through the drying chamber. So this becomes a forced convection solar dryer or active solar dryer. So it can be used for large scale commercial drying. Like,
sir, 1 second, sir. Can you show us the previous slide?
this one?
Thank you, sir. Thank you. Thank you.
Should I?
Thank you, sir. Thank you.
So this type of system can be made bigger because we can have number of solar collectors. So large amount of air can be got heated if we collect large amount of solar energy, and we can make the drying chamber, this drying chamber bigger, or can have number of such drying chambers, and hot air can be supplied to all. So For large-scale commercial drying, the active solar dryers are used. So in the end, again, we see that solar dryers can be natural circulation and forced circulation. For both, for natural circulation as well, we can have direct solar drying, we can have indirect solar drying, we can have mixed mode solar drying, and similarly for the forced convection solar dryer, we can have all the three, direct, indirect, or mixed mode solar dryers that we will see in the coming slides as well. I will share you some studies that have been carried by the people. I will share those studies with, like about the natural circulation solar dryer that we have seen. Some people are using single glass cover, some are using double glass cover. That depends upon the location where we are located. If the temperature, ambient temperature is very low, we will go in for 2 or 3 glass covers. The number of glass covers depend upon the temperature difference between the inside of the dryer and temperature difference of the surroundings. Because we want to achieve temperature close to around 60 degrees centigrade, and if the ambient temperature is say less than 10 degrees centigrade, we will go in for double glass, and if the temperature is still less, we will go for 3 glasses. But normally for the Indian conditions, we go in for single glass. And now the other things, like it is a, you can say, direct solar dryer. It is integral because the solar collector and drying chamber are combined in a single unit. And the other thing that is not in favor of it is its absorber is horizontal. The solar radiation are absorbed on a horizontal absorber. And it is preferred that the absorber should be inclined as per the latitude of the location, so as to capture maximum possible solar radiation. Since its absorber is horizontal, it will capture intercept lesser amount of solar radiation. So its drying capability will be affected. And similarly, we have another study done by another scientist. It is reported in literature, like instead of the glass cover, this has been covered with the transparent plastic polythene sheet. This will reduce the cost of the solar dryer. But when we change the glass with plastic sheet, the performance of the dryer will reduce. The greenhouse effect that we expect to be produced with glass will not be produced with transparent polythene sheet. But it will be lesser costly, its cost will be less, but the performance at the same time will be poor. The other things that are not in favor is that, like I discussed in the previous slide, is horizontal aperture. So it will intercept lesser amount of solar radiation. So that is the thing that is not in its favor. And another system that has been reported, it is also similar to that. We have a direct, it is similar to cabinet dryer. We have a tray here on which the product to be dried is placed. There is an opening at the bottom through which air goes in, and a chimney has been provided for air outlet. Because of chimney, the flow of air will be more. So as compared to the earlier dryer, the drying in this may be, the airflow in this may be better. But again, here we have a horizontal aperture. That is the one of the deficiencies that will cause lesser interception of solar radiations. And next, this we have is a staircase type of dryer. It has been made inclined. So its inclination can be fixed as per the location, as per the latitude of the location. We can fix the inclination so as to capture maximum possible solar radiation. And the trays remain horizontal. These are the trays and they remain horizontal. And product is placed on the trays, and there is opening underneath the trays through which the hot air is flowing. And chimney has also been provided at the top for higher airflow. So in this case, it has advantage of inclined aperture. The solar radiation interception would be better, and better airflow will be there. And this is another dryer that is popular in African countries. That is a shell dryer. Here we have this is the top, that is a metallic. This is openable. On this metallic top, the solar radiation are absorbed, and on the lower surface of we have two cones. One is this cone, and the other is the inverted cone there, on which the product to be dried is placed. By opening the top cover, we can place the product, and holes are provided on the sides, and at the center, opening is provided for air outlet. Air comes in through the side holes. But here in this case, what happens is absorber is at the top. So the hot air will cause the flow of air, but the heated absorber may not transfer the heat to the product which is being placed in the drying chamber. So, but it will cause the higher flow of air, better flow of air. So the this absorber is not being utilized in a proper way, you can say, and at the same time it is unglazed absorber. It is exposed to wind as well, so the losses from the absorber will be high. So these are the points that are not in favor. So only aeration is being happening in this dryer. But this is an indirect solar dryer, indirect and integral. And another design that we have is an indirect natural convection solar dryer. Here it is the simple solar dryer that we have. It is a solar collector at the bottom through which the hot air goes up to the drying chamber. And then we have at the top a chimney for air outlet. So here we have inclined aperture that captures the maximum possible radiation. We can fix the aperture as per the geographical location, and chimney we have for higher airflow. And this dryer is a indirect type because the heating of the product is being done in the solar air heater and drying is done in the drying chamber. And then we have a next dryer, that is a natural convection solar dryer again. Here we have a mixed mode solar dryer. In the earlier case, we had at the top plywood covering in the drying chamber. If that covering is replaced with the glazing glass, then the radiation will fall on the drying product. So that becomes an mixed mode solar dryer, from the indirect solar dryer here to the mixed mode solar dryer by changing the upper top layer of the drying chamber. And then this is another dryer developed by the Braced Institute. Here we have what they have done is, this is a mixed mode solar dryer. We have a solar air heater here, and at the top is a drying chamber, and they are using charcoal as an absorber. So as to make it low cost, they are making use of charcoal here that absorbs the heat, and that heat is transferred to the air. That air moves up through the drying chamber to the through the chimneys, and then goes out. So, and then this is another natural convection solar dryer. These are the small variations that have been carried out by many researchers. Like this is the solar air heater they are having, and at the top they put the fiberglass sheet for solar radiation input, and on the front side again they have clear plastic sheet for solar radiation input. So this again becomes a mixed mode type of solar dryer. Heat is coming from the solar air heater as well as directly from the solar radiations. And this is another dryer in which the insulation, the bottom insulation has been changed. Instead of normal glass wool or like the one used as charcoal, here they are using burnt rice husk here. That acts as insulation as well. That acts as absorber as well. So air moves in, takes heat from the burnt rice husk and moves upward. And this is another solar dryer. Here they have made use of a wind ventilator at the top. Because of the wind ventilator, the airflow through the solar collector and drying chamber will increase. That is the advantage here. The airflow will be better. But what we see the disadvantage, like at our location, like in Punjab, what happens is when the sun is shining brightly, there is no wind generally. And when the wind starts blowing, the weather is, when the weather is not good, only then the wind starts blowing. Then if the weather is not good, then the temperature will not rise in the solar collector as well. Then the air will be flowing at a faster speed. It will not allow it to rise almost the same ambient air with a few degree, 5, 6 degree rise in temperature will be going through the drying chamber. That seems the disadvantage in this case. Otherwise, in this case, this drying chamber is well insulated. Now, this is another solar dryer with wind ventilator. Here, this drying chamber is not insulated. It is insulated from the one side, from the back side, from the north side, you can say. So on the front side, it is we are provided with glazing so as to allow the solar radiation. So this is another variation that has been done by the researchers. And this is another design of solar dryer, reverse absorber cabinet dryer. We have a drying chamber here, and the air is, this is the absorber. Below the drying chamber, this is the absorber, and solar radiation is falling through this reflector onto the absorber, through this glazing onto the absorber, and this absorber is getting heated. And it is expected that the air, which the surrounding air will come in, that will pick up the heat from here and move upward through the crop, and by removing the moisture and then leave at the top. This is, in this, what is felt is that here in this direction, the pressure drop is more as compared to in this direction. It is expected that a very small quantity of air will move up. Some of the air may go out as well, because in this direction, the pressure drop is very low as compared to passing through the crop. So here we have a solar collector on the lower side. It is, so that is why it is called the reverse absorber. Then next, coming to the greenhouse type solar dryers. This is a simple greenhouse type solar dryer. Here we have two platforms on which the product to be dried is placed on the two sides, and then at the, it is covered with the glass roof, and at the top, at the center, opening is provided for air outlet. So air passes through the coming in from the lower side will come, may pass through the drying product and leave at the top, or it may also bypass this product placed on the drying product. It may also directly go upward. So that may be an issue, that the air may not, air comes here, gets heated, move at upward and leaves at the top. That is also possible, that air bypasses the drying product, hot air doesn't come in contact with the product to be dried. And in the greenhouse dryers, we have a problem of large heat loss area. In the drying chambers that we had were completely insulated. But in this case, we have a same opening through which the radiation are coming, so we cannot insulate. And the one more thing, the radiation will coming from the south direction. We cannot have inclination on the two sides. It is not advantageous. The radiation will come from one side only. The radiation will not come from the north side. So this is another type, another greenhouse that was developed by some author. It is simple. The platforms are placed in the greenhouse and it is covered with the plastic sheet. The plastic sheet generally used is a UV stabilized that can withstand the environment for about 5-6 years. Here again we have a problem of high heat loss area. because the radiation will be coming from, most of the radiation comes from the south side, a small amount comes from the east and west side, but no radiation will come from the north side. So that large area on the north side contributes to only heat loss. These are the other designs that have been made, this is again a tray type, or here it is a rack type of solar dryer. Number of racks are there on which the product to be dried is placed. Again, in all the cases, the disadvantage is large heat loss area, and we are allowing access area on the north side as well, through which no radiation is coming. And this is another design. A chimney has been put so as so as to have better airflow through the drying chamber, through the greenhouse. The airflow will be better, and drying is expected to be better. And this problem remains the large heat loss area. And then we have a greenhouse dryer with solar collector. This is the greenhouse that we have, and the trays are placed here. Tray racks are there. And then it is coupled with a solar collector, like this section you can see. It is a plastic sheet with bubbles over it, so as to have lesser heat loss. So, and this is also a plastic sheet, but it is a normal plastic sheet, single layer. So air goes in, passes through the first solar air heater, and then second solar air heater, which is better insulated, and then through the drying chamber. This is so this solar dryer is coupled with solar air heater so as to enhance the temperature. So the temperature of the inlet air will be quite higher, about 10-15 degrees centigrade higher, as compared to the earlier dryers, in which case we have seen the ambient air was coming in. In this case, the heated air is coming into the dryer that is being utilized for drying in the greenhouse. So its performance will be better as compared to the earlier dryers. And then we have forced circulation solar dryers, are also called the active solar dryers. There are few designs that I will discuss with you. This is the simplest design of forced circulation solar dryer. We have a drying chamber and a solar air heater, and that is connected to a air blower. So air is forced through the solar air heater. The heated air from the solar air heater is then passed through the drying chamber, and then it goes out with drying some of the moisture of the drying product and leaves at the top. So here we have an inclined absorber, because here we have an independent drying chamber and solar collector. So we can optimize them independently. We can incline the solar collector as well as per the need. And then we have a rotary column cylindrical dryer. Here it is almost same as compared to, as the earlier one. We have a air blower and then solar collector, which is inclined at a certain angle. And then this is the cylindrical drying chamber, which is rotating continuously with the help of a motor, and hot air enters the drying chamber and leaves at the top. This is generally used for grains, grain dryings, like if we have to dry maize, paddy, then it is used. Then we have forced circulation solar dryer. It is just a very simple design. It is a, you can say, the cabinet dryer here, and this is a platform on which the product to be dried is placed, and we put a air blower on the side and force the air through the product. So this is a very simple design, just putting a fan to the cabinet dryer. Here it is possible that the heat air may bypass the drying product. Air may go in this direction, or it may directly go, because it will follow the path of least resistance. It may go as it is. Then this is a tunnel dryer that was developed in Germany. It is like at here we have a large length of solar collector, and it's two parts, you can say, solar collector and then drying chamber here. Here the product to be dried is placed. It is also covered with a plastic sheet like here, and the solar collector part is covered with a double layer. And a fan is used to force the air from the solar collector through the drying chamber and then goes out. It is a mixed mode dryer, hot air is going in and the radiation is directly falling on the drying product as well. And here the disadvantage is we are having horizontal absorber, but it can be used for large quantity of drying product. And it is similar to the earlier one. We have some portion, this marked one as solar collector, and then we have a drying chamber where the drying product is placed. So air comes in from this side, and we have a air blower here. Air goes out from this side. So air is heated initially and then passes through the drying chamber and then leaves. So this is a mixed mode type of solar dryer. Here we have a disadvantage that the glazing is inclined of the solar collector is, you can say it is inclined, but it is better to have either at least a horizontal glazing if we cannot have the, because it is inclined in two opposite directions. The radiation will falling only from the south direction, no radiation will be coming from the north direction. If the radiation are more inclined on the glass, they will get reflected. They will not enter the solar air heater, so they will not be utilized. That is the disadvantage here. The radiation utilization will be lesser because of the opposite inclination. And this is another design of forced convection tunnel greenhouse dryer. Here you can say the bottom, it is divided into two parts, this lower one and the upper one. This bottom is divided into three parts. At the center we have a drying chamber through which the drying racks move. These trolleys move, and on the sides are solar air heaters, like these are the collector zones. The hot air from the sides is sucked in and is then forced through this tunnel. It is also sucked in from the sides and from this duct, you can say here, partially, that is circulated and then pass through the trolleys, passes through the product and then leaves at the other end. And the air leaving at the other end is partially utilized and is partially thrown out. That is there. Because as the air leaves at the end, all the drying capability of the air is generally not utilized. It still has some moisture, still has some capability to remove the moisture. So it is circulated. It will help in gain in temperature of the air that is inside the dryer. And these were the simple type dryers, like can be natural circulation or can be forced circulation, and then greenhouse dryers were there. And then some people have tried solar dryers with heat storage. Heat storage is done when we have to want to utilize the solar radiation that are collected during off sunshine hours. We can extend the drying hours. Otherwise, in a normal solar dryer, the drying hours will be during sunshine hours, generally 7 to 8 hours, like from 9 to 4 p.m. or 5 p.m., like that, about 8 hours. After that, the dryer will not work, then again, it will work the next morning. And for drying most of the agricultural products, it takes around, you can say around 30 to 40 hours, drying hours. So in a day, about 8 drying hours are there, and so the drying is extended to 3 or 4 or 5 days, like that. But if we can extend the drying hours, then the total drying days will reduce. That is the advantage in the case of heat storage. If we can store the solar radiation that are coming and utilize during off sunshine hours, then we can extend the drying hours. Like this is the simplest solar dryer. It is like we have seen the solar collector here, and at the this is the drying chamber, the product to be dried, and in between we have there are rocks. This is the heat storage material they have placed. The hot air from the solar collector passes through these rocks. It gives heat to these rocks, and then after giving some of the heat to the rocks, passes through the drying product and drying the product. In this way, these rocks will gain some temperature till evening. because all the air is passing through them. So when the sunshine is not there, even then the air which is in contact with the rocks will get heated, it will move upward, it will continue to move up. That's the advantage. We can extend the drying hours for say 2 or 3 or 5 hours depending upon the quantity of rocks we put here. But here the disadvantage is that in the morning, if we are getting the temperature at the outlet of solar collector, say at 10 a.m. Around 50 degrees centigrade, but that air will pass through the rocks and there will be drop in temperature because heat will be transferred to the rocks, and the temperature at the inlet to the drying chamber here will be lesser, around close to 40 or lesser than that. So in the morning, we will get lower air temperature. The advantage, it is the sizing, how we size the rocks and how we size the solar collector, that has to be done so as to take the proper advantage of the heat storage. So this is the cycle. Here they have put a mirror as well, so as to concentrate the solar radiation onto the collector, so that the temperature rises to a higher value. So this is the general circuit: air inlet and then passes through solar collector. It is heated with mirror as well as solar collector, and then thermal storage, drying chamber, and then leaves. This is another type of solar dryer that is using the storage. Here we have this is the storage here. It is a 2-pass solar air heater. The air is going upward and then coming downward. The absorber is here. The air, heated air will go in this direction and passes through the grain dryer. So this is the storage that I placed. The heat will be, some of the heat will be gained by this storage. Here in the front, we have a glass windows they have provided so as to allow the radiation to pass. So it is a mixed mode type of solar dryer. And this is another method. Here the insulation below the solar collector is rocks. So that is absorbing the heat as well, acting as a heat storage as well as insulator at the same time. After sunshine hours, it will release the heat that may continue for 1 or 2 hours. And then another possibility is solar dryer with thermal backup. The advantage of solar dryer with thermal backup is that we can get assured drying. Like if we use electric drying as compared to the solar dryer. In the solar dryers, because of the weather condition, the temperature may drop sometimes because of cloudy weather. But if we have a thermal backup, that thermal backup will come into picture and increase the temperature to a desired value. Like this is the simple solar dryer with electric backup. We have a solar collector here, drying chamber here, and in between we have a electric heater, that is auxiliary electric heater. Like if we want a short drying, we want the temperature at the inlet to drying chamber as say 60 degrees centigrade always. Then in the morning, the air temperature at outlet will be 40 degrees centigrade at 9 a.m. This auxiliary air heater will come into picture, raise the temperature by 20 degrees centigrade and dry the product. And when during noon time, when the temperature reaches close to the desired temperature, say 60 degrees centigrade, this will not work and the hot air will go as such. So in a way, this will give us a short drying, but the cost will increase because of the electric system attached with it. And then there is another option that has been explored by many as the biomass backup. In addition to the solar dryer, like we have a drying chamber here, the product to be dried is placed here. Radiation is falling directly on the produce. So it is a solar dryer, direct solar dryer, and it is being heated from the bottom with the help of biomass gets burnt here, and heat is supplied to the lower surface. Solar dryer with biomass backup. In this case, we don't have good controls like that we have in the case of electric dryers. But during off sunshine hours, it will be beneficial. Like when the sun is not there, we can use the biomass to do the drying. Similarly, in the same way, number of other options like LPG backup, and these diesel backup, these have been tried as well. And then coming further, we have a PV assisted solar dryer as well. Solar photovoltaic assisted solar dryer. Like in the solar dryer, generally power is required to for the fan. Like we have a solar collector here, drying chamber is this, a fan is there. And this fan is powered with the solar cell. Instead of powering the fan from the main grid, from the AC electricity, generally a DC fan is used and solar photovoltaic panels are used to power that fan. The advantage in this case is that instead of using the main grid to supply the electricity, PV powered fan, we can use this at a remote location because it doesn't have any dependence on electricity. Like this is another dryer we have seen like earlier as well. This is the solar collector here, and this is the further drying chamber. And the fan here that is powered with the photovoltaic panel, these are provided at 0.3. Instead of the fan powering with electricity from grid, it is powered with photovoltaic panel. That's the only difference from the earlier dryer. And then we have a heat pump assisted solar dryer. Like this is the circuit you will see say for the heat pump. This is compressor, and then refrigerant comes to the condenser, then expansion valve, and then evaporator. This is the circuit for the heat pump. And in this case, in the heat pump dryer, what is done is air from the drying chamber goes into the evaporator, where it releases its moisture, and its moisture is absorbed here, moisture is released here, and then that air is passed through the condenser where it gets heated, and then this hot air is passed through the drying chamber. And this works in a closed circuit. That is a heat pump dryer. We are having heat pump, one circuit, and other circuit is a air circuit in which we place the drying chamber. And this heat pump dryer can be powered with the solar energy as well, like heat pump assisted solar dryer. Like this is the circuit we have for the heat pump. This is the compressor, and then condenser, and then expansion valve, and then evaporator. This is the circuit for the heat pump. And this is the another circuit. We have a drying chamber here, and air from the drying chamber goes to the evaporator where its moisture is removed, and then that is passed through the heat exchanger where heat from the solar air heater is coming. We have a solar air heater here, air is coming here, that transfers heat to the air coming from the drying chamber, and it gets heated, then it is passed through the condenser. Its temperature is increased further. That air is then used to remove the moisture of the drying product. It is recirculated in the same way. So that is how we can use solar energy to power heat pump dryer. But the economics is not favorable in this case, although the drying will be faster, but the economics is not there. And then we have a desiccant integrated solar dryer. This is another solar dryer in which desiccant is used. Desiccant, I think you may be understanding that it absorbs the moisture. It absorbs the moisture in the surrounding air. So here what is done is, those are specific materials, desiccant, like we have a zeolite, silica gel is there, and then liquid desiccants are there, lithium chloride, and other number of liquid desiccants are also there, and solid desiccants are there. Like here, they have placed a solid desiccant here. It is a solar collector and then drying chamber. Here it is a blower. In the daytime, hot air from the solar collector passes through the drying chamber and leaves at the top. So normal drying operation is carried during the daytime, and the sun is also falling on the sun is also falling on the desiccant. Because the sun is falling on the desiccant, whatever moisture the desiccant has, it will release the moisture because of heating. It is being heated. So there is opening provided here for inlet of air and outlet. This air will carry the moisture and dry this desiccant during the daytime. During daytime, the desiccant will get dried. Then in the evening, this partition is removed. So this desiccant and this product in the drying chamber are in contact with each other. So the moisture in the product, this will be the cycle moisture in the product will move to the desiccant, and the dry air will again come down and remove the moisture and go up to the desiccant, where it leaves the moisture to the desiccant. So during evening, the desiccant will gain the moisture, and during when it has gained the moisture, then the drying will stop. And during daytime, this moisture is again removed from the desiccant so that we can use it in the evening hours. That is there. That is a desiccant integrated solar dryer. Not many designs are available. This is the only one design that is available in literature of the desiccant. And next I will be discussing with you the solar dryers that we have developed. We have developed solar dryers of all range, like small capacity solar dryers as well as big capacity and medium capacity solar dryers. I will show you those designs as well. And then honey dryer and seed dryer we have also developed. Like this is a small capacity solar dryer that we have developed. Here we have it is a natural circulation solar dryer. Here we have 3 trays. It has inclined aperture so as to intercept the maximum possible solar radiation. And 3 trays are there on which the product to be dried is placed. Openings are provided at the bottom and at the top for airflow. Here the advantage is the one advantage is its inclination can be changed. Like we have provided these tray stoppers. With the tray stoppers, we can change the inclination depending upon the latitude. So if we are using at a different latitude, we don't have to make a different dryer. We can use the same dryer and change with the help of these stoppers, like in this position or in this position, the inclination of the dryer can be changed by 15 degrees. The tray remains horizontal in both the cases. That is the advantage. So that is one factor that is in its favor, that it has a variable inclination depending upon the latitude of a location. The another thing is on the drying tray, we have a shading plate that can be put on the drying tray. Like for the products, the photosensitive products, we need to have shade on the drying product so that only the heated air pass through the product. Drying is carried by heated air and no direct solar radiation fall on the produced. Shade is there on the product. But the drying is faster if the solar radiation fall directly on the produce. Like for those cases, if we have to dry turmeric, ginger, in those cases, the quality is not affected by direct sunlight. So in those cases, we can remove this shading plate, only this tray is used, so that drying is faster in those cases. So we have an option to dry in direct sun as well as indirect mode. And then it's mounted on a wheel so that we can store in a room when it is not used. And then there is another design. It is also a small design that we have recently made. It is of the same capacity, 2 to 3 kg. Here we have a solar collector at the bottom, and at the top we have a drying chamber. Like this is the drying chamber we have, and there are 2 trays. And these dryers we are selling through our department as well. These are being sold. And then we have in the medium capacity dryer, this is the one dryer that is a very low cost. It is made of a plastic sheet. It has inclined aperture. It has plastic sheet front as well as on the back side as well. It is made of plastic with insulation of thermocol. Like we have number of trays, around 7 trays are there on which the product to be dried is placed. and it is made in such a way that it can be dismantled when not in use. We can dismantle it entirely and store it, and when it has to be used, it can be again assembled, because generally for farms it is not used throughout the year. And it is also of a similar capacity dryers, but its cost is higher as compared to the earlier dryer. It is evacuated tube collector here. These are the evacuated tubes for air heating, and we have a solar panel here for running the fan, which is fixed at the top, and this is the drying chamber. It is a simple design. The hot air from these tubes goes into the drying chamber and leaves at the top. The evacuator tubes have very high efficiency of around, like evacuator tube, solar and water heaters have efficiency of around 50 to 60%, as compared to flat plate collector, which have efficiency in the range of 30 to 40%. So because of higher efficiency, we can get higher temperature and the drying is faster. And this is another view. This is the view that when not in use, it can be pushed under the evacuator tubes. And the advantage here in the case of evacuator tubes is that they remain almost normal to the sun throughout the day, because for the evacuator tubes, the projected area, the direction of the projected area will change, because they are cylindrical in shape. The interception is much more as compared to that of the flat plate collector. And its efficiency is quite high. Even we have tested the quality parameters, the food parameters like chlorophyll content, ascorbic acid, color for the fenugreek leaves, and they were found better. And similarly for turmeric, we tested the polishing loss, recovery of powder, curcumin content, volatile oil content, color. They were found to be better for this dryer as compared to the other dryers. And then we have a large capacity. This is a large capacity dryer. Generally, we recommend it for a capacity larger than 100 kg. We can make it for any capacity. And it is similar to the greenhouse dryer. We have a polyhouse here, and in the front we have solar air heaters. And this polyhouse is, in this polyhouse we have a tray racks on which the product to be dried is placed. This is not the hemispherical polyhouse you may see. It is vertical on the north side. This is the south side we have, and it is vertical on the north side. Because the radiation are coming from the east, south, and west side only, no radiation will come from the north side. So that has been made vertical so as to reduce the heat loss area. Only the heat will be lost. So it is vertical, and it is insulated with thermocol sheets, so that no heat will flow outside through that wall, north wall. So that has been done, and the solar air heaters supplement the temperature of the greenhouse as well. Even without solar air heaters, because of the insulation of the north wall, we are able to achieve quite higher temperature as compared to the general greenhouse. With this, we are able to get around 30 to 35 degrees centigrade higher temperature than the ambient temperature. This is the schematic. You can see these are the tray racks inside the greenhouse, and we have a solar air heaters. It is powered with the electric blower. That electric blower can be powered with the photovoltaic panels, or we can use the main electricity grid supply line for it. And then there are exhaust fans for removal of air. Now in this case, we have air recirculation. In these solar air heaters suck the air from the greenhouse, heat in the solar air heaters, and then supply to the greenhouse. So there is a air recirculation. So continuously the temperature of the air inside the dryer continues to increase. And exhaust fans are used only when the inside humidity increases above a limit we have set 55%, or if the temperature in the greenhouse exceeds 65 degrees centigrade, then the exhaust fans are switched on, or the humidity level is above 55%, then the exhaust fans are switched on. Otherwise, there is no heat loss to the surroundings. Continuously, there is no heat loss. That is the advantage in this case. This is the inside view of the solar dryer, and this is the solar dryer powered with photovoltaic panels. And without photovoltaic panels, we have found that approximate running cost with electricity is about 3 rupees 3 and 70 paisa per kg of dried product. And this is the area requirement. This is for different capacity dryers. And then if the dryer is powered with the photovoltaic modules, then area required is more for the photovoltaic module as well. And then I will just briefly go through the salient solar dryer installations that we have done. Like this is the solar dryer installation at a society. They are using it for drying of turmeric, garam masala and vegetables. For pickles need to be dried, they are using that. And this is of 700 kg capacity. And then this is another dryer that is of same capacity. And then this is for drying of vadiya, like the lentil donut. These can be dried. This is installed in Ludhiana. That this is installed on the rooftop, and its cost was just 98,000, and the average monthly saving was around 20,000, like that. And he was able to recover the cost within a year or so. Within less than a year, the cost was recovered. And this is another installation at the user site in Talwada. They are using it for drying of amla candy, amla powder, like these things, bitter gourd, moringa leaves. And this is another installation. And these are some of the videos. I think I can skip that. And then we have a honey moisture reduction system using desiccant. This we developed way about 10 years back. Like here what we have is generally for honey, when the honey is harvested, its moisture content is in the range of 23 to 25%. That needs to be reduced for a longer shelf life. Otherwise, it will ferment. So the moisture content needs to be reduced to below 17% so that it can be stored for a year and longer. So in this case, what we did was, this is a chamber in which honey was put, and there are circular discs which kept on rotating, and the dry air from the desiccant is used to dry the air. The dry air from the desiccant is supplied to this chamber of honey, and that removes the moisture and then goes back, and that moisture is given to the desiccant bed again. Again the dry air comes in and removes the moisture. This is the cycle we have. And the honey was heated by putting it in a hot water bath, and that water was circulated, and it was kept at a temperature of around 44 degrees centigrade, because we cannot go to a higher temperature beyond 50 degrees centigrade. Otherwise, the quality nutrients of the honey will be destroyed. That is the problem. That is the system. This is the honey chamber. These are the discs you can see. And then about this is the another system, small scale honey. Here we have a streams. This is again the honey streams. This is the honey chamber. This is honey flowing. Coming here, it is flowing in the form of a streams, and we are flowing hot air over the streams for the removal of moisture. This is a simple system, and honey is heated with the help of hot water bath, which is maintained at 45 degrees centigrade. This is, and this is a tray for honey stream, and this is the photographs you can see for the honey streams. And this is another arrangement for seed drying. For seed, like we have seen for drying of crops, we can go to a temperature of around 60-65 degrees centigrade or 70 degrees centigrade. But for drying of seed, we cannot go to that temperature. The germination of seed is affected. We cannot go beyond 45 degrees centigrade. If we go beyond that, the germination of seed will not be there. So seed have to be dried at a lower temperature. So for if we are to dry at a lower temperature, we dry with low humidity air. So that, for that we make use of desiccant. By passing the air through the desiccant, we get the low humidity air. That low humidity air is passed through the seed bed, and that is circulated throughout the day. After, in one batch, this seed will get dried and this desiccant bed will get wet. Then that desiccant bed has to be regenerated. The moisture from the desiccant bed has to be removed. Then that is removed with the help of solar air heaters by forcing hot air from solar air heater through the desiccant bed. The moisture of the desiccants is driven out, and then it gets again ready for the drying. Then that regenerated desiccant is again used for drying next batch of seed. So that is a desiccant seed dryer. This is another type of by inversion of flow desiccant seed dryer. Then the other applications, the small application that we discussed at the start, the other applications are solar thermal water pumping system. These are there, but the economics of these systems is very poor. Like for water pumping, it is based on the Rankine cycle. Like this is the Rankine cycle. We have a blower. From the blower, we go to the expander. From the expander, the power is used for the water pump. And from that, it goes to condenser and blower. This is the circuit we have. The expander supplies the power to the water pump. In the blower, we require boiler, we require heat. That heat is supplied from the solar collector to the blower. So in this way, the solar energy can be utilized for water pumping. But this process is, this system is very costly. We will have to put a large number of solar collectors, and they are not able to compete with the other energy devices like photovoltaic and even electricity. It will not compete. So not much research is going on in this direction. And the another system that we have is a solar thermal refrigeration system. Some of these systems are being used, and the simplest cycle that we have, it works on the absorption refrigeration system. Like this is the absorption refrigeration. This is the generator where we have a absorbent and refrigerant combination, and the refrigerant goes here in the condenser, and then we have a expansion valve, and then this is the evaporator where cooling is done, and then here the absorbent from this generator and refrigerant get mixed. This is the absorber, and that mixture again comes to the generator. And here in the generator we need the heat. That heat is supplied with the help of solar energy. We have a flat plate collector array. From there we can supply heat and to the generator for the separation of refrigerant and absorbent. Refrigerant will go. So, but because the absorption system has a very low efficiency, and the solar system will also not work throughout the day. So because of that, this technology has also not picked up much. It is all in the research stages. Only the potential that we see today is in the solar drying. And thank you very much. That's all.
Thank you, sir. Thank you, sir, for your interesting presentation on solar thermal applications in the field of agriculture. You elaborated on various methods of solar drying methods, including direct, indirect, and mixing, and also some latest techniques used in applications like heat pump, desiccant integrated solar system, and you highlighted that experimental works as well as case studies at Punjab Agriculture University, Ludhiana, and some other place like Hoshiarpur. And thank you for sharing more useful information in the field of solar agriculture. In addition to this solar drying, you also briefed about solar pumping, solar refrigeration, etc. And if time permits, maybe 1 or 2 videos also we would like to watch in the field of solar agriculture. We have a lot of videos I also watch on YouTube in solar drying system. Maybe at least one video you may play to our participants. It's my request.
Yeah. Please unmute your mic.
Please share the screen, sir.
Should I share the screen?
For video. Kindly play one video, sir, on solar agriculture. You have video.
Should I play the video?
Yes.
Okay. Like these are the reviews of some of the users. Are you able to hear the sound?
No, sir. Video is not coming now. I am seeing the PPT.
Are you able to hear the sound of the video?
No. Video is not playing. Actually, video is not playing. We are seeing presentation, PowerPoint presentation, reviews. Hindi. The hyperlink is, I am seeing the hyperlink.
Like this one. I'm not able to
Yes.
hear sound.
Yes, sir. I think it's coming.
This is the
Yes.
installation
Yeah, came, sir.
for drying of dented donut.
Nice. Yeah, yes, came coming, sir.
These dryers are being manufactured by a private manufacturer. We have transferred this technology to a private manufacturer.
Okay. Okay, sir. Thank you. Thank you, sir, for your wonderful and interesting presentation. And now I request the participants to interact to our speaker.
Sir, good
Hello.
evening, sir.
Hello.
Hello.
Yes, yes.
Dr. Sab, really appreciate the great effort, and we just came across a variety of the dryers based on the solar. My only concern was that this design effort, who's making the design effort? Is it your at the university level?
Pardon?
Design effort.
Design, right.
These have been designed, and now the technology has been transferred to a private manufacturer.
Like,
He
sir,
is
who are the people? Who are the people responsible? Because you are trying to develop. How much time it takes for the making of a prototype and the acceptability and the application of the use. Yeah,
like I have shown you this dryer, the bigger one. This
G G.
dryer around up till now he has sold around 15 installed at 15 locations.
Like TOT, your transfer of technology takes place in which form? Design or drawing sort of thing? There are the proper design or prototype copying is taking place.
It is both ways. We even guide him, we give him the drawings, even we guide him for manufacturing of the dryer so as to ensure that the proper quality of the product is manufactured. Even we
That's
visit the site for initial dryers installations. We visit the site and monitor the performance for few days.
Yeah,
That is done.
that's that because it's a big effort. It's a very big effort, and
Like
uh,
this manufacturer has even installed the dryer at Dehradun, and now he is installing at further places in Uttaranchal as well. He is installing
that's
in
nice.
Leh as well.
Now we are quite happy, sir. It's you are getting substantial royalty also, maybe.
No, we are not getting royalty. We have got one-time payment.
Oh, good. Ji sir.
It
Ji
is
sir.
just one-time payment for technology transfer, and it is
Yeah.
non-exclusive transfer. We can, if anyone else wants to manufacture the dryer, he can also take the technology from our
Yes, sir.
university and manufacture it.
Sir, thanks a lot. I must appreciate the really very great effort. Thank you very much, and be blessed, sir. So kind of you. Thank you, sir.
Dr. Mohan Jagdish Kumar wants to ask some question. Dr. Mohan Jagdish Kumar, you raise your hand.
Yeah, yeah. Good afternoon, sir. Exactly.
Sir, regarding
Yes, go ahead.
Go ahead.
sir, when it comes to the solar air dryers, how it could be assessed in terms of performance, because the efficiency will be very poor. And I could able to see in many papers they are trying to adopt some passive and active techniques. So have you come across anyone said that the performance is very poor, so that you have to include certain active or passive techniques? Have you included any kind of techniques to improve the solar air heater performance?
No, we are using the evacuator tube solar air heaters that are the most efficient up till now. The design of the as compared to the flat plate collector. At lower temperatures, even they got the good performance. Uh, and making use of air blower, we are making use of air circulating fans inside the dryer. Air circulating fans are there so that there is a proper air movement for faster removal of moisture from the product that is there.
Yeah,
It is
fine, sir.
it is a
Fine.
it is a combined. You can say that like you are saying, it is a combination. Active mode has to be used, like you are saying. It has to be used for better drying, faster drying.
Okay, thank you, Professor. Thank you.
Sir, is it approved by any agency? Suppose
No,
is that
it is approved by Punjab Energy Development Agency and Indian Council of Agriculture Research. It is approved by ICAR and Punjab Energy Development Agency. They are taking up on a bigger scale. We have
okay?
got the
Any mass production or IOC certified your organization?
No, actually, we have designed the dryer and transferred the technology to the private manufacturer. And as per the orders, he is manufacturing this dryer. And the other dryer, like the vacuator tube dryer, he is also manufacturing and selling it.
Okay. Thank you, sir. Thank you.
Any else from participant side? Sir, from chat box, I saw two questions. One is one participant is asking which is the best one, ideal or ideal solar dryer, direct or indirect?
Which is?
What is the ideal solar dryer? Is it a direct type solar dryer is better, or indirect type solar dryer is better in performance point of view, maybe?
Yeah, like that only depends upon where we want to utilize and
Yes.
for which product we want to utilize. It is these are the specific things. For
Yes,
one
yes.
situation, the direct will be better. For the products that are not photosensitive products, for those products, the direct dryer may be better.
Yes, yes.
For the other products, the indirect will be preferred.
Sir, one more question from chat box. One participant is asking what is the refrigerant used in the heat pump?
What is the?
You showed some heat pump. In heat pump.
Yeah.
Heat pump based solar dryer. What type of refrigerant they use? What the name of the refrigerant is asking?
What is the about the heat pump dryer?
Refrigerant name. What is the refrigerant?
Can you repeat that question?
What is the name of the refrigerant used in the heat pump? What is the name of the refrigerant?
Refrigerant.
Refrigerant.
Refrigerant that I think that was R133 or like that. Exactly, I don't remember now. Because this is not the system that we have developed. It is the system available in literature that I am showing. I don't exactly remember which refrigerant it was.
Okay. Okay.